Hi guys, welcome to my channel Archer Infotech. After several requests, I'm starting this series. So to encourage us, please do like, share and don't forget to subscribe. So now today let us succeed with the C programming. In the C programming, the most important part initially we want to focus on is what do you mean by computer and why we are using computers, as well as we must go thoroughly in the what do you mean by language and its usage, and what the computer languages means, and what you mean by programming. Okay, so let's start with the computer. There are several different advantages of computer, and therefore we are using the computer near about each and every sector. So let us start with some characteristics of computer. Okay, so here are some characteristics of computer. There are several different advantages, therefore we are using computer. Okay, so characteristics mainly include the speed, means as compared to human being, the computer works in a tremendous speed, as well as it will work with an accuracy. There are several different sectors where we can use the computer. Huge storage is provided. It is a reliable machine. Is it able to work 24/7, and it able to work on multiple tasks simultaneously. Okay, it is possible to provide a procedure to perform the task, and also its availability is a main important part. Okay, na? And it gives the cost effective solution. Okay, and understanding these characteristics in our day-to-day life, computer become a part of our daily routine. See, there are different application areas. So let us concentrate on application areas of computer. Okay, so there are different application areas. So next point is application areas of computer. See, near about in each and every sector nowadays computers are used. Okay, na? So it become a integral part of our modern life. Okay, na? And the sectors which includes, and it is just for the example, okay, which are listed over here. Okay, na? So these are some sectors where computer can be used. So which includes entertainment, education, transport, business and finance, data analysis, cyber security, personal use, artificial intelligence, simulation and modeling, in government sector, in agriculture industry, okay, na? In science and research, healthcare. So these are some examples. Near about in each and every field we are using the computers. Okay, so after the characteristics and different application areas, let us concentrate on what do you mean by computers. Okay, now let us concentrate on what do you mean by computers. Okay, in simple term, computer is data processing unit. Computer is data processing unit. So consider this as a black box which takes input and which gives the output that you want. Okay, na? In case of computer, input is a data, and this black box is actually processing unit. And after processing the data, it will give the information. So therefore, in a simple terms, computer is defined as it is a data processing unit. So what the data means? Okay, now what the data means? It is actually facts, properties, characteristics or measurement of entity under consideration. Okay, now suppose you are thinking about the pen. So data about pen is price, company, the refill it has, the color of writing, that is the data. Suppose I am thinking of storing the data of a student. So when I am thinking of student, his personal details, his academics detail, the curricular activities, information of curricular, co-curricular activities, extra co-curricular activities, hobbies and interests. Okay. So that is the data. When I represent that data in a well formatted manner, it become his CV or biodata. Okay na? So after processing data, it get converted into information. So what do you mean by information? What do you mean by information? It is a well processed data, or it is a well organized data. Okay na? So you can define a computer in another way as it is a two-state multi-purpose programmable electronic device which takes input from user, store it, process on it, and gives output in a desired format. So why two-state? Because it knows the binary. It knows the binary. Why multi-purpose? Because there are various areas of application. It is a programmable because it is possible to assign or to feed the procedure to perform the task. And as it is made from different electronic components, it is called as an electronic device. So first part of this definition is about the computer, and counterpart is about his role. Okay na? So computer is defined as it is two-state multi-purpose programmable electronic device which takes input from user, store it, process on it, and gives output in a desired format. Okay na? See, let us concentrate on hierarchical diagram of computer. The computer is divided into two different parts, that is a hardware and software. See, basically hardware is a part of computer having a physical existence which we can touch and feel. Okay, and software basically huge set of instruction. We can't touch and feel it, but it is possible to observe its effect. It is possible to observe its effect. Okay na? So hardware, computer is divided into hardware and software. See, hardware is further divided into CPU and peripheral devices, and CPU is further divided into control unit, arithmetic and logical unit, and internal memory, whereas peripheral devices are divided into input devices and output devices. Okay. See, peripheral devices contains the input devices like scanner, keyboard, mouse, and output devices like screen, printer, and sound boxes. Okay. The software is further divided into system software and application software. The system softwares are the software programs having direct access to memory and hardware. Okay na? So operating system is one best example of system software because it gives access to memory and hardware. Again, device drivers are there. So device drivers are the small or tiny program which acts as software interface between two subsystems. So when you connect pen drive to your CPU or to your laptop initially, then you will get the pop-up at right bottom, that is the installing drivers. Okay na? Means these are the device drivers. Okay na? Again, language processors. So we know that computer don't have a IQ. Okay na? So we required to feed, we need to feed a procedure to perform the task. Okay, and for that we need to communicate with the computer, but there is a language barrier. Computer knows binary and we are unable to feed the instructions in binary. We are able to write instruction in English like language, na? In English like language, but computer don't know English, so there is a language barrier. To fill that barrier, we need a software program which will text the instruction written in English like language and convert into machine understandable code. Okay, and when machine process the data according to instruction given by us, and it will give the output in machine understandable code. Again that software program converts the result into human understandable language. So such kind of software programs are known as a language processors. Okay na? As operating system, device drivers and language processors interact with memory and hardware directly, it comes under the system software. Application softwares are actually developed according to the user's need. Okay na? Application softwares are actually developed according to user's need. Okay na? So different CAD/CAM softwares are there, antivirus softwares are there, different media players are there, Word, Excel, PowerPoint means MS Office is there. So these are the examples of application software. Okay na? So now we'll proceed further and let us concentrate on the hardware first. Okay na? So we'll elaborate the CPU, and we must know the functional block diagram of computer. Okay na? The functional block diagram of computer. Actually, the functional block diagram provides the overview of computer. Okay na? Means see, it will give the clear idea about each and every block of computer, as well as it gives what happened with the instructions and the data, and how the instruction and data transferred through the different blocks of computer. Okay na? See, this is the functional block diagram of computer. Okay na? So this block named input represents all input devices, whereas this block output represents all output devices, and the central part combinedly known as CPU, that is a central processing unit. When you feed the data or instruction, they are initially stored into internal memory. Okay na? The instructions are input to CU. CU is a control unit. So according to those instructions, the CU generates the command signal to every connected peripheral. Okay na? And if the data is there, and if you want to process the data, that data is input to ALU, where ALU stands for arithmetic and logical unit. It will perform arithmetic operation like addition, subtraction, multiplication, division, as well as logical operations like ANDing, ORing, XORing, bit shifting, etc. Okay, it acts as a calculator of computer. It will take the data from internal memory, and the final result as well as intermediate result is again stored into internal memory. And if such instructions are there, then the processed data again displayed to or represented to outside world with the help of output devices. So for an input, keyboard is considered as a standard input device, whereas for output, screen or a monitor considered as an output device. Okay, see, we'll see in a next point. The memory, internal memory, is divided into RAM and ROM. Okay na? So as a programmer, a RAM is accessible for us, and which can be used or which is used to store the data as well as the instruction. But that RAM is volatile in nature. Means once you turn off the supply, the contents get cleared automatically, get flushed out automatically. So if you want to store the data in a permanent manner, then you need the external storage. Okay na? So here EM represents the external memory. So You can store the data in external memory permanently, and you can take or you can load previously processed data which is present on external memory. You can take that data for a reprocessing also. So this is about the functional block diagram and a role of each and every block. Now let us concentrate on memory. As you all know, memory is a storage area or storage media. Memory is storage area or storage media. The memory is further divided into internal memory and external memory. It is also known as a primary and secondary memory. Okay, now the internal memory is further divided into temporary, permanent, volatile, non-volatile, or long term and short term. The RAM, which stands for random access memory, is a short term, temporary, or volatile memory, and ROM is permanent, non-volatile, or long term memory. So ROM stands for a read only memory. Actually ROM contains the system monitor routine, which defines or which contain to decide the functioning of individual subsystem present within the CPU, or which is a part of motherboard. Okay, now so pre-programmed ROM is a simple ROM. PROM is a programmable ROM. Initially it is a blank, you can write the program within it. EPROM is a erasable programmable read-only memory. You can erase it, and for erasing technique high intensity UV rays are used, and for the erasing purpose when you use high voltage electricity, then it becomes electrically erasable programmable read-only memory. Electrically erasable programmable read-only memory. So these programs are written by system programmers. Okay, na? And these are inserted or copied or embedded within the ROM at the time of chip burning process. Okay, na? So that is done by system programmers. So we want to be a developer, means software programmers. So we need to deal with the RAM only. We have nothing to do with the ROM, because it contains the system monitor routine and which is handled by system programmers. Again, the external or the secondary memory, normally it is a permanent memory which contains the hard disk, CD drive, DVD, pen drive, memory chips, or memory cards. Okay, na? See, to know the programming concepts clearly, we need to concentrate on the read-write operation and the memory units. Okay, na? So let us see how data flows throughout the system and how it is stored. We know that the data flows in terms of electrical signals throughout the system. Electrical signals throughout the system. But see, electrical energy can be stored, but it is hardly impossible to store the electrical signals directly. So it can be stored in a magnetic form. Means see, suppose we want to store the A in the memory. Every symbol is represented with a binary string, a fixed or a unique binary string. which is assigned by a standard system, that is ASCII. Okay, now assume that, see, this is the bits binary string associated with that character A. So it is transmitted from one point to another point in terms of electrical signal, like this. When there is a one high amplitude signal, when there is a 0 low amplitude signal, 0 low, again 1 high, again 1 high, again 0 low, and again 1 high. So like that. Means, see, this is the electrical signal. So in the circuit, from one point to another point, this A is transferred from one point to another point by means of electrical signal like this. Okay, see, when you want to write it, the signal is passed through one coil. Generally that coil is called as a read-write head from the hard disk. Okay, now suppose this square represents the hard disk, the memory area from hard disk. It is actually made from the ferromagnetic material where actually data is stored. The property of ferromagnetic material, that is, it contains lots of NNS particles randomly moving around it. Okay, now when a coil or a read-write head rested on it, which is time shared, when this signal pass, it will create the charged sector when high amplitude signal, and empty or uncharged sector when you pass the low. So these signals are represented in magnetic form, as shown over here, where @ symbol represents the charged sector and dash represents the uncharged sector. So this is the write operation. This is the write operation. Okay, now see, the charged sector finally represents the 1 and uncharged sector represents the 0. So even though there are different number systems, so together with binary, octal is there, hexadecimal is there, decimal is there. Okay, now in hexadecimal 0 to 9 and A to F there are 16 symbols. In octal 0 to 7 8 symbol. In decimal 0 to 9 10 symbols. In binary only 2 symbols, that is 0 and 1. And note carefully that magnet having only 2 states, that is charged and uncharged. Okay, so mapping become very easy. Okay, now, and due to that, actually computer knows binary, or binary is used in the computer system. Okay, now, so we have seen the write operation. Now let us concentrate on the read operation. When same coil connected across the load and it moves like this from start to end, the flux link with coil changes because this partition charge sector is there. Means there is a magnetic field, no? So intensity of magnetic field changes as that coil moves around it. So the flux link with coil changes, which will induce the EMF in it, and EMF is responsible for electromotive force. So depending upon the charged uncharged sector, it will generate the signals like this, which is same as that of the signal used for the write operation. Okay na, means same signal is regained back. Okay na, so after quantization it is converted into the binary, and after comparison with ASCII set or ASCII codes, the original symbol is regained back. Okay na, so this is the read write operation. So now the interesting fact is that we know the bit. Okay na, so what is the bit? So let us see, or let us talk about the memory units. Okay na, so basically bit refers to binary digit. So bits, see, bits means collection of zeros and one, collection of binary digits. So bits, how it is formed? Bi from binary, and this ts, last ts, from the digits. So it forms the bits. It forms the bits. Okay na? So 0 or 1 refers to binary digit, that is binary bi, and the last character of digit is t. Okay na? So collection of 4 bits forms 1 nibble, collection of 8 bits forms byte. Okay, 1024 bytes 1 KB, 1024 KB 1 MB, 1024 MB 1 GB, and 1024 GB 1 TB. So which is the smallest unit of memory? So nibble is a smallest unit of memory. See, we talked about the ASCII na? So ASCII stands for American Standards Coded for Information Interchange. So this is the code convention system. Okay na? So for the proper data transfer, the bit sequence associated with every symbol must be same throughout the world. So American based company provided standards to make the information interchange properly. Okay na? So these are the actually standards coded for information interchange. We know CGS standards, MK standards. Okay na? Like that, these are the standards which are provided for the information interchange. The CGS and MK standards for the units. Na? So like that, these are the standards for information interchange as they are developed by Americans. These are known as American Standard Code for Information Interchange, abbreviated from ASCII, that is ASCII. Okay na? See, let us talk about ASCII codes. Suppose this is a and assume this is the bit sequence provided by ASCII. So its decimal equivalent is a 65. Therefore generally we see, or we say that the ASCII code of capital A is a 65. Okay na? So like that, A to Z, capital A to Z is within 65 to 90, small a to Z is within 97 to 122. See, 0 to 9, 48 to 57. So these are some ASCII codes. Okay na? And see, finally the concept of addressable memory the concept of addressable memory is quite important. It is actually the memory area from RAM where we can store the instructions as well as the data, intermediate result and final result. So when we allocate the memory area in program, so it is from addressable section. So considering TC, the addressable memory is a 64K, that is 65,535 bytes only. Okay na? So this is all about the hardware that we have seen basically in the hierarchical diagram of computer. So let us concentrate on software, and as we have seen or as we have discussed, the software is actually huge set of instructions which don't have physical existence. We can't touch and feel it, but it is possible to observe its effect. Okay, so the language, to know the software, the language become a more crucial part. So what is the language in general terms? It is a way of communication. Okay na? So generally we are talking with each other na? So that is a verbal communication. If you want to communicate with some people or your friends which are far away from you, so generally you can write a mail, you can WhatsApp, or you can write a letter. That is a symbolic communication. The differently enabled persons who can't speak or talk, they uses the different signs using hand. That is a sign communication. Okay na? So we are using the symbols present within English language. Here in C we are using the symbols of English language, so it become a symbolic communication. Okay na? We are using the symbolic communication. So generally language is termed as a it is way of communication. It is a way of communication. So what do you mean by programming languages? So these are the languages which are used to communicate with computers. So generally defined as it is a symbolic communication, it is a set of symbols together with some rules which are used to communicate with computer. Okay na? So as discussed earlier, we are using the English to communicate with computer. But does computer knows English? No. So which language computer knows? Okay, now which language computer knows? Computer knows binary. Computer knows binary. So as a human being, we are unable to feed the instructions in binary. Okay na? So only it is possible to write the instruction in English like language, that is in human understandable language. So somebody must be there which will convert the code written in English into machine understandable code. Okay na? Into machine understandable code. And vice versa, means when machine work according to it and generates the results which is obviously in machine understandable language. So same application should convert it into the human understandable language. So that software program is actually called as a language processor. That software program actually called as a language processor. So language processor, what is its role? The language processor converts the human code into the machine code and vice versa in simple terms. So assembler is a language processor generally used for the assembly languages like microprocessor, microcontroller. And interpreter and compiler are the language processors used in a higher level language. Okay. See, the role of interpreter and compiler is the same, which is this. But the way of doing it is quite different. Means interpreter, when interprets the code, first of all, entire code divided into number of blocks. It will take one block, the interpreter will take one block, convert it into machine understandable language and execute it. So it will perform the operation in same style till it will not encounter the error or it will not reach at the end. Suppose error is there, it will stop there. So it will not continue further unless and until you eliminate that error. Okay, na? And again in the same style it will proceed further. But in case of compiler takes entire code, all the lines as an input. Okay, compile it, and if some errors are there, it will provide the least of errors. Okay, na? To proceed further, you have to eliminate all the errors. Unless and until you eliminate the error, all the errors, the program become error free. It will not convert the code into that executable file after some steps. Okay. Means it will take the entire code, and when it become error free, it will convert it into the executable file. Okay. So here in C we are using compiler. Okay, now we are using compiler. So let's see the execution flow of the C program. So this is the execution flow of C program. Okay, now this is execution flow of C program. So when you are writing the C program, means what? You are writing the instructions, and finally when you completed, you will save it with some program name. Means instruction plus program name forms the source code, having an extension star.c in a C programming and star.c++ in CPP, star.cpp in C++. So where star represents the program name. So this code is taken by compiler, and converted into the star.bak, which is a backup file. So it is converted into backup file only when the source code is error free. When there is an error, it will generate the compile time error. Normally, at the compile time, syntax errors are there, like semi-comma is missing, undefined variable. Okay, and in absence of any error, the code is converted into backup file, the backup file having extension .bak. Again, after backup, the linking process, the code merger is happened over there. See, after that it will form the obj. Basically, obj contains The machine understandable code, it is actually machine understandable code of instruction written by you, as well as the pre-compiled machine understandable code of the functions that you have used in the program. Means merger or mixing of machine understandable code of instruction written by you and the pre-compiled machine understandable code of the functions that you have used, built-in functions that you have used in the program, is called as a linking process, which is done by the linker. And after successful linking, the object code file is created having extension star.obj, which is actually machine understandable code. And when any mishap is there, it will generate the linker error. Just for example, misspelling of printf. Okay, see that object code, when that object code is generated, then it is bundled into special package called executable file, it having extension .exe. So this is actually completion of compilation process. So after successful compilation, there are 4 different files present in the memory, that is star.c or star.c++, star.bak, star.obj and star.exe. Okay, when you execute the program, actually executable file, that is exe, is executed. Means exe, when you run that, you will get the output. So due to incorrect input, you may face the error called as a runtime error. And see, when any error occurred there, then again you have to make change in a source file, and again go for the compilation process. Again, if error is there, then again you have to eliminate that error. So the bug, bug, which is, or which means the error, bug is synonymous word for the error. So debug is actually process of error elimination. Okay, it is actually process of error elimination. So this is the execution flow of C program. Now we want to learn the C programming. So let's talk about programming languages, different types of programming languages, and where C stands. Okay, now where C stands. So there are 2 different subtypes of programming languages, lower level languages and higher level languages. Okay, now lower level languages and higher level languages. See, lower level languages contains the assembly languages like microprocessor, microcontroller, whereas in a higher level language, there are different languages like COBOL, Fortran, Java, C++, VB, C#, Python, etc. Okay. So what about C? Is it lower level language or it is a higher level language? It is a middle level language. Why it is known as a middle level language? Because it contains the features of both higher level as well as lower level languages. Okay, now higher level as well as lower level languages. Okay, means C, like a lower level language, C interact directly with memory and hardware, which is a feature of lower level language. No? And like a COBOL, it is a structured programming language, which is a feature of higher level language. So as it contains features of both higher level as well as lower level language, it is known as middle level language. Okay, see, that's it for the introduction chapter. So we'll continue in the next lecture. Okay, thanks for the watching, and please do share, like and subscribe. Thank you very much.